Okay, prove that if k is more than 4, then k squared is more than 2k plus 1. Okay, k squared more than 2k plus 1. That means k squared minus 2k minus 1. We need to show that that's more than 0. That means we need to show that k minus 1 squared minus 2, isn't it? Is more than 0. And that means that we need to show that k minus 1 squared is more than 2. So okay. Actually, I'm kind of going backwards through this. I'm starting here and I'm trying to arrive at this. But if does it have to be as much as 4 though? So if I square root both sides, that means k minus 1 is greater than root 2 and k minus 1 is less than minus root 2, but k is positive. So we're done. So you could have actually gone backwards. You could have said k is bigger than 4. Oh yeah, so if I want to make... So I could do it backwards actually. So you could say k is bigger than or equal to 4. So that means k is bigger than or equal to root 2 plus 1, which means k minus 1 is bigger than or equal to root 2, which means if I square both sides, k squared minus 2k plus 1 is bigger than or equal to 2. And if I take everything to the right, k squared is bigger than or equal to 2k, and then 2 minus 1 is 1. So that's done. Now, 2. Case, what's the first case? 4. Prove that the first case is true. 2 power 4, is that bigger than or equal to 4 squared? 16 is equal to 16, that's true. That's actually, yeah, so that's question 2, part 1. Now part 2, assume case k is true. That is 2 power k is greater than or equal to k squared. Just assume that's true. And then 3, we're required to prove 2 power k plus 1 is bigger than or equal to k plus 1 squared. So the trick with these is start with the 2. So from 2, you have 2 power k is bigger than or equal to k squared. Now, if we multiply both sides by 2, that means 2 power k times 2, that's bigger than or equal to 2k squared, which means 2 power k plus 1, that's bigger than or equal to 2 power k squared. So now we're required to prove that 2 power 2 times k squared, that's bigger than or equal to k plus 1 squared. Okay. So that means we need to show that 2k squared is greater than or equal to k squared plus 2k plus 1, which means we need to show that 2k squared is bigger than or equal to 2k plus 1. But that's true from part I of the question, part 1 of the question here, since we start at 4. So that's the end of that proof, that part of the proof. So 4, 1 plus 2 plus 3. That means it's true for n equals 4, 5, 6, etc. Oh, sorry, I wrote 2k squared there, didn't I? Sorry, I took the k squared over, so that's just k squared. 2k squared minus k squared is k squared. And now it matches up with it. Sorry about that. Yeah, okay.